My name is Chandrapal. I have graduated from National Institute of Technology, Rourkela in Applied Geology in 2022. Today, I was discussing about the shale gas and unconventional natural gas. It's about introduction and their geology and difference from the distance in the shale gas and conventional gas and its worldwide reservoir and their effect of the environment. So let's begin. So firstly, introduction. So shale gas is an unconventional natural gas that is found trapped within shale formation. So what is shale? Shale is fine granite clastic sedimentary rock. It forms it formed from mud and flakes of clay mineral hydrous aluminum phyllosilicate. Example of phyllosilicate is kaolin. That chemical formula is Al2SO5OS4. And tiny fragments of other mineral, especially quartz and calcite. So shale has a property of of fish fish facility. So now what is the fi- facility? The shale is characterized by its tendency to split into thin layer less than 1 centimeter in thickness. This property is called facility. So shales are deposited in ancient seas, river deltas, lakes, and lagoons, and are one of the most abundant sedimentary rock types. Shale is trapped in microscopic or submicroscopic pores of shale deposits. Natural gas is mixture of natural occurring hydrocarbons produced from the decomposition of organic matter like plant and animal remains. Shale gas consists of 70 to 90% methane, and this gas is used for generating electrical for domestic heating and cooking. Now geology. So geology about the shale gas is there. Here we can see there because shale gas ordinarily have insufficient permeability to allow significant fluid flow into a wellbore. Most shales are commercially source of natural gas. Shale gas is the one of an unconventional source of natural gas. Others include coal bed methane, tight sandstone, and methane hydrate. Shale gas are areas are also known as resource plaza as opposed to exploration plaza. As we can say that there is a conventional deposit of the oil and natural gas is found in the normal depth, but in the shale gas deposit found in the 150 meters of 5,000 feet. Here we can see the tight gas deposit and the shale gas deposit. Shale gas is term of used to describe both tight gas and shale gas resources. The main difference between tight gas and shale gas is that tight gas can be found in low permeability sedimentary rock such as sandstone, while shale gas rock are usually impermeable. So shale gas is produced or held in shale deposits. some in natural structure में पाए जाते हैं, some in pore spaces, and some is absorbed onto the cell matrix. So the gas is structure is produced immediately. The gas absorbed onto organic material is result as the formation pressure is drawn down by the wave. Daily, the first economic quantity of gas rich in organic material is 0.5 percentage to 25%. They have mature petroleum force rock in therefore Jenkins window where high heat and pressure have converted petroleum to natural gas. They are sufficient brittle and rigid enough to maintain open fracture. Now, as we can see there the difference between the shale gas and conventional gas. So first we will talk about the hydrocarbon. Hydrocarbons such as oil and gas are produced by the transformation of organic matters like plants, animal, algae as a result of increased temperature and pressure. But in contrast with shale gas, the shale gas resource form within the organic cells of rock. In hydrocarbons, the conventional gas reservoirs are created when natural gas migrate toward the Earth's surface migrate toward the Earth's surface, form an organic formation into highly permeable reservoir rock when it's trapped into a overlying layer of impermeable rock. But in shale gas is a form of unconventional hydrocarbons because the rock it is extracted from active source reservoir and epoch both. The gas is produced, stored and stored within impermeable shell and can be released only after the shell is drilling and artificially structured during an extraction process. And the hydrocarbons migrate upward where they may find their way into porous reservoir rocks and overlain by an impermeable cape. The hydrocarbon become trapped in reservoir rock. Conventional hydrocarbons can be extracted by drilling directly into reservoir rock. The low permeability of shale greatly inhibits the gas from migrating to more permeable reservoir rocks without horizontal drilling and hydraulic fracturing. Shale gas production would not be economically feasible. Hydrocarbon gas reservoirs are usually called fields, but the shale gas reservoirs are called basins. Worldwide reservoir resources. In 2015, the total amount of unproved technically recoverable reservoir of shale gas was estimated to 240.6 trillion cubic meters across 46 countries. Now, here we can see that in the worldwide that China has the most most shale gas deposit is 1,115. After that, after that is China. There is there is Argentina, then Algeria, then United States, Mexico, and Canada have the most shale gas deposits in the worldwide. Now we will begin about the worldwide resources. The largest estimated resources are China in 31.6 TCM, followed by Argentina 22.7 TCM, Algeria 20 TCM, and United States 70.6 TCM, and Canada 16.2 TCM. However, United States and China hold up the highest production of shale gas in the world. China 14.3% in Asia, and the US, Canada, and Mexico in North America 29.2% are the largest technical recoverable reserve found in the world, according to US Energy Information Administration in 2015. Besides the majority distribute reservoir, technically recovered reservoir are also found in region of Europe. Europe is Ukraine, Poland, France, UK, Denmark, and Netherlands. The rest significant countries in terms of long-established hydrocarbon production like Algeria, South Libya, Russia, Libya, and Egypt are supposed to have 9.1% to 1.3 of total habitat. Projection by the US Energy Information Administration in 2006 estimated that the shale gas would account for 30% of world natural gas production by 2040. Now we will discuss about the exploration and exploration of the shale gas. So shale gas naturally are obtained from silicate formation of shale frequently at depth of extent 15 meter, 15,000 meter or 5,000 feet. Within the impermeable sea rock, the gas is trapped and sealed in unconnected structure and pores for gas production in commercially quantities requires fracture to provide permeable. This requires specific extraction method for its production. Hydraulic fracturing and horizontal drilling are the used to increase the flow rate of gas in the shale gas rock. Earlier it's produced from the shale gas with natural fracture. The shale gas boom in recent years has been due to modern technology and hydraulic fracturing of fracking to create self-artificial fracturing around the world. Shale gas was the first extracted resource in Florida, Europe in 1821 in shallow low pressure fracture. Horizontal drilling began in 1930s and 1947. A well was first taken in the US. So here we discuss about the horizontal drilling. Horizontal drilling is often used with the shale gas well when lateral length up to 10,000 feet or 3,000 meters within the shale to create maximum borehole surface area in the contact with the shale. First, a vertical well is drilled to large target rock formation at the desired depth. The drill bit is turned to a bore a well that trails through the reservoir horizontally, exposing the well to more produce material. Here we can see the drilling of shale gas well in research technology. Here the shale gas deposit is more vertical, so that well is vertically drilling. But in this condition, the shale gas deposit more horizontal than vertical, so here the horizontal drilling is going for the scraping the shale, for the exploration the shale. Now we will discuss about the hydraulic fracturing or cracking. In shale deposit must be still contained in shale source rock. The problem for production is that the diffuse is an extremely slow rate to extract through unconventional means. In fracking, deep holes are drilled down into shale rock, followed by horizontal drilling to access more of the gas as shale reservoirs are typically distributed horizontally rather than vertically. And next, fracking fluid containing sand, water, and chemical are pumped at high pressure to drill holes to open the fracture in the rock. It enabling the trapped gas to flow into collection wells from there it piped away from the commercial use. When used in conjunction with horizontal drilling, hydraulic practicing enabling gas produced to extract shale gas at reasonable cost. Without these techniques, natural gas does not flow through the field rapidly, and commercially quantities cannot be produced from the shale. Now we will discuss about the economy of shale gas development. Here in the past decades, innovation in hydraulic fracturing and horizontal drilling has fueled a boom in the production of natural gas as well from the geological formation. Primarily, deep shale in which hydrocarbon production was previously unprofitable. A Vision Again research report calculated that in 2050, 2011, worth of the global shale gas market is 26.6 billion US dollars. One of the byproducts of shale gas exploration is the opening up the deep underground shale deposits to tight soil or shale oil production. PwC report says that by 2035, shale gas production could boost the world's economy by a 2.7 trillion US dollar. It has the potential to reach up to 12% of world total oil production, touching 14 million barrels a day, revolutionizing the global energy market over the next 2 decades. Now, with increasing demand for combustion reliability, several nations are on the path of shifting their energy consumption toward the natural gas. As we can see that with the consumption of the see in of projection of the consumption and production of the shale gas is increasing day by day after 2 to 4 decades. Now we will discuss as the shale gas industry. As we know, the shale gas is natural gas and is not harmful for the environment. But in the shale gas industry, there is an environment issue. So as we will discuss about the environment issue of the shale gas industry. So first is the climate. In 2010, the U.S. Environmental Protection Agency issued a report which concluded that shale gas emit large amounts of methane, a potential greenhouse gas. The end is conventional gas, but still is far less than coal. Methane is a powerful greenhouse gas, although it stays in the atmosphere for only one-tenth as long as speed of as carbon dioxide. Recent evidence suggests that the methane has global warming potential that is 105-fold greater than carbon dioxide when viewed over a 20-year period and 60-fold greater than viewed over a 100-year period. And then after we discuss about the water quality and issues of the shale gas industry. So chemicals are added to the water to facilitate the underground fracturing process that release natural gas. Fracturing flood is primarily water and approximately 0.5% chemical additivity. Machines, depending on the size of the area, millions of liters of water are used. This means that hundreds of thousands of liters of chemicals are often injected into the subsurface. The main issue with the shale gas industry is the earthquake. In hydraulic fracturing, routinely produced microseismic events much too small to declare affected by sensitive instruments. These microseismic events are often used to map the horizontal and vertical extent of the fracturing. However, as of late 2012, there have been three known instances worldwide of hydraulic fracturing so induced trigger make large enough to felt by people. Over 109 small earthquake of magnitude 0.4 to 3.9 were detected during January 2011 to February 2012 in the Youngstown, Ohio area where there were no earthquakes in the past. Among the 109 so 12 events greater than magnitude 1.8 were detected by regional network and accurate relocated, where 97 small earthquakes that magnitude is 0.4 magnitude to 1.8 were detected by waveform correction detection. Now, the conclusion of the shale gas industry and the shale gas deposition. The shale gas extraction have revolutionized the natural gas industry, so it can be concluded that shale gas play an important role in extending the aspect of zero emission and restricting the effect of greenhouse gases. As with the cult of supply has become much controversially, environment concern over the contamination of water source and the effect of tampering with the raw formation deep underground remain due to relative influence of hydraulic fracturing. Despite not being an environmental friendly as much as renewable energy source, natural gas is really an improvement from the use of coal and oil as the source of energy. So here we discussed about the ability of resources worldwide along with the continent and determined them for their effort of shifting fuel consumption for domestic and commercial purposes. So that's about the shale gas deposition and shale gas. So these are the reference that I have used in during this presentation. Thank you. Okay.